Howdy, students. So we have uh, our systems of equations assignment. Now, there was a lot in this assignment. Um, those of you that gave it a good, honest shot, awesome. So this video might be a little long because there were a lot of errors in the submissions that I got, but they're in many different places. So I feel if I go over this really thoroughly, hopefully everyone will be able to learn something from this particular video. Okay, so first we need to start off with understanding we're doing a systems of equations and they're linear equations. We could do systems of equations with one of the equations graphing as a curve, another one graphing as a line, one graphing as a single point in space. I guess that wouldn't be an equation, but we can have different designs on the graph, and those different designs or graphs can intersect in different ways. But when we're talking about systems of linear equations, and actually let me even add that here, linear equations, because there's quadratic equations. Anyway, so we've got two lines, which means they don't intersect at all, they intersect once, or they're the same line. And hopefully you remember me going over that in class. So we're going to see what happens. Now, linear equations can be represented in a lot of different ways. The equation can look very different in different, it can be organized differently. Okay, there's some standard ways to organize it. There is the slope-intercept form of a linear equation. That's y equals mx plus b. That is one way to organize it. Another way to organize it is in standard form, which is a coefficient times x plus a coefficient times y equaling a constant. And we looked at this in class as ax plus by equals c, where a, b, and c are all rational numbers, which means they can be 0, they could be 1, they could be 0. They can be 0, they can be 1, they could be -1, they could be positive a half, negative a half, any of our rational numbers. Okay? Now, and actually, I think they could be irrational too. They could be any real number. But we typically used integers, all right? 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, things like that. Okay, moving on. Let's see this particular problem. So in this particular problem, we're given two equations, 4x plus 2y equals 6, and another equation which we're going to see here in a minute. But the first thing you were asked to do in your assignment, actually let me go ahead and show that. The first thing you were asked to do in your assignment was to find the x and y intercepts. So intercepts, when it comes to linear equations and the coordinate plane, intercepts are where your line crosses either the x-axis, the y-axis, or another function. All of those are different intercepts, or another equation, okay, or another line. All of those are intercepts, right? I want you to think of, this is kind of a weird example, but let's say a rock being thrown at a kite, right? That rock can be thrown in front of the kite, behind the kite, to the side of the kite, but if the rock is thrown in such a way that the kite flies into the rock and both of them moving through space collide together at a single point, that point is where their paths intersect. Okay, so the kite is going along one path, the rock's going on along another path, and where those paths cross is a point of intersection. Okay, well, these intercepts that we're looking for, so we have a point of intersection with the two lines, but when we talk about the each axis, the x and the y, we talk about an x-intercept. Okay, very similar word, but it's where the line it's where the axis intercepts the line, so the line's passing through it. Okay. That happens on the y-axis when x is 0, which means we don't move forward or back on the x-axis, we don't move left or right, we only move up and down on the y-axis, and if the line crosses the y-axis, and it doesn't have to, but if the line crosses the y-axis, then that is called the y-intercept. And we will have a y value, but we won't have, our x value will be 0, okay, because every point along the y-axis, x is 0. Okay, same thing on the x-axis. When we have an x-intercept, that means y is 0, because every point on the x-axis, y is 0 because we didn't move up off the x-axis into positive y's, and we didn't move down below the x-axis into negative y's. We stayed right on the x-axis, and that's when y equals 0. Okay, so what we do to find those points is we substitute in 0 for x when we're looking for the y-intercept. So here's our equation. First equation, 4x plus 2y equals 6. So what we do is we say, okay, what happens if x is 0? I put 0 in my table. I put x equals 0 up here to remind myself what I'm doing. And then I substitute in 0 for x. Now, because of our 0 property here, we have 4 times 0 is 0, and anything plus 0 is just itself. So basically, this whole term goes away when we multiply 4 times 0. And we're left with 2y equals 6. We need to isolate y, okay? And we need to recognize that what's going on between the y and the 2 right now is multiplication. So we need to divide by 2 so that 2 becomes 1, and I'm going to be really explicit with it down here. So we need to divide away the 2. So we're going to divide by 2. When we do that, we have to divide every term by 2. So let's say we didn't get rid of this 4 up here. We had to divide by 2 originally way up here at the top. We would have to divide this by 2, this by 2, and this by 2. Okay? We would have to divide everything by 2. But at this step, we only have a 2y. That's one term, and a 6. So when we divide by 2, we divide away the 2 here, and we have to divide 6 by 2. Now, I was really explicit in this step because I want you to see this. 2y divided by 2, we end up with a 2 divided by 2. And you guys know, anytime you have a number divided by itself, that's 1, and 1 times anything, and in this case anything is y, 1 times anything is itself. So 1 times y is y. On the right-hand side, we had 6 divided by 2. That simplifies quite neatly into 3. So if we follow our process, when x is 0, y is 3. So in our table, we substitute 0. We don't substitute. We enter in 0 in the x column and 3 in the y column for this equation. All right, now we're going to do the same thing for y. Up here, same process. I'm going to say y is 0. This is going to give me my x-intercept because we are not going to move up and down on the y-axis. We're only going to see where does the line cross on the x-axis. Okay? Y is 0, so 2 times 0 after we substitute right here. 2 times 0 is 0, and anything plus 0 is itself, so that just comes down in the next step. We're not even messing with the 6 at this point. Okay? But here we have nothing else to do to isolate x other than divide by 4 because we have 4 times x. There's no other step we could take. Doesn't make sense to subtract 6 from both sides because that doesn't get x by itself. We're trying to isolate x. We're trying to determine what x is. And remember, the equal sign is the is in math. So we want x is, so just x all by itself, not 4x. X is a number. All right, so we need to get rid of this 4. So we divide by 4. 4 divided by 4 is just 1x. On the right-hand side, did 6 divided by 4. I left it as a fraction so you could see it, and then I reduced it as a fraction so you could also see it as a fraction. And I wanted to show this extra step because I could have very easily left it like this, right? But I know I'm going to have to graph this. And if I'm going to have to graph this, it's going to be a lot easier graphing a mixed number than it is an improper fraction. So I'm going to go ahead and convert my 3/2 into 1 and 1/2. Not really convert, I'm going to rewrite it as 1 and 1/2, okay? So I come back to my table. And in my table, when y equals 0, x, through our process of solving here, is 1/2. All right, so we did this for the first equation. Now, it's at this point that I would go to my graph and graph those 2 points, draw the line in between them, and be good to go, okay? However, for the sake of this video, we're going to go ahead and find the intercepts for the second equation, okay? So we're just on a roll here. We're just doing the same thing for the second equation. All right, same process. X equals 0. I substitute in 0. 2 times 0 is 0. 0 minus y gives me a negative y. Okay, now here's where things might get tricky. You're like, oh shoot, well what do I do now? Do I have to add y to both sides? Long story short, you could, but that's a lot of extra steps. Instead, you know you just need y by itself, and this negative is in the way. So if you divide a negative by a negative, you know it's going to be positive. And if we divide y by 1, we know anything divided by 1 is itself. So we end up with a positive y. Perfect. So if we're going to divide by a negative, we need to divide both sides of our equation by that negative. So a negative divided by a negative is a positive. Y divided by 1 is y. A positive divided by a negative is a negative. 7 divided by 1 is 7. Okay? So when x equals 0 here in our table, y equals negative 7 here in our table. Okay? These two values correspond into a single point on the graph. All right? We're going to do the same thing over here when y equals 0. Oh, this is nice, right? We substitute in 0 for y. 2x minus 0 is just 2x. Perfect. Now here we're going to have to divide by 2. 7 isn't a multiple of 2, so we know we're going to end up with an improper fraction and mixed number, right? 2 divided by 2 is 1. 1x is just x. 7 divided by 2 is 7 divided by 2, or 7 halves. 7 halves simplifies into 3 and 1 half, right? 2 goes into 7 3 times with 1 remainder, 3 and 1 half. Okay? So I put in y equals 0 in my table. When y equals 0, x equals 3 and a half. Okay, so then now you know that your graphs have to relate to the equations. The equations and the graphs are two representations of the same function. Okay, it's the same thing. So it's like the word zebra and a picture of a zebra. Both of those relate both to the same animal, the zebra, right? So it's not just a separate word that's totally disconnected from that picture. They're both connected to each other. So here our equations are connected to our graphs. And our equations right now are connected to those x and y intercepts. So let's use the x and y intercepts to graph. We come down here to our graph. Okay. Now you'll recognize I cut and paste these tables out of my work, right? These are the x and y intercepts of the first equation. These are the x and y intercepts of the second equation. So I'm going to start here. X-intercept. When x is 0, y is 3. So when x is 0, that means I don't go forward or back on the x-axis. I stay there. X is 0, y is 3. And I move up to 3. 1, 2, 3. I plot the point, and I write the coordinates for that point. I'm labeling my graph. All right, so that's 1 point. I only need 2 points to draw a line. Between any 2 points, a line can be drawn. Okay, that's a rule you got to know. So the second point is my y-intercept. No, excuse me, my x-intercept. The first one was my y-intercept because it's where my line crosses the y-axis. My apologies. The next one is the x-intercept, so it's where the line crosses the x-axis. And on the x-intercept, y is 0 because I don't get off of the x-axis. I don't go up into the positive y's or down into the negative y's. So y is 0. X is 1 and a half. So when y is 0, x is 1 and a half. I plot that point. I label the point. X is 1 and a half, comma, y is 0. Okay? Now between those 2 points, I line up my ruler, bam, draw my line. Okay? Now I'm even going to label my line. So these intercepts came from this equation, right? 4x plus 2y equals 6. So I'm going to go ahead and label that line so I know which line is which. These are also color coordinated. This is in pencil. The line is in pencil. This is in red pen, honestly, over pencil because I did it as an afterthought. And that red pen matches this red pen. Okay? So let's move over to the red pen line and say when x is 0, y is negative 7. So we are doing our y-intercept. So x is 0, we aren't moving back and forth, and we just go straight down to negative 7 for the y. So this is our y-intercept. Okay? For our x-intercept, x is 3 and a half and y is 0 because we're staying on the x-axis. So we need to go to 3 and a half. 1, 2, 3 and a half. Plot the point, draw the coordinates for that point. Okay? Now between this intercept and this intercept, I line up my ruler, I draw my line, that's my line. Every other point on that line can be plugged into this equation and it should work. Every single one, it should work. That line represents all the infinite possibilities of combinations of x's and y's where 2x minus 1y will equal 7. Every time, any point, I could select this point up here, a point, a mile off of this graph in the upper direction. All right, doesn't matter. Any point on that line should satisfy that equation. Okay. So if this line represents the other first equation, the red line represents the second equation, where they intersect should be a point where at that point both equations are true, and that's the solution. That's the solution we're looking for. So because I drew this accurately, I used a ruler. Notice I did this on notebook paper, guys. I know a lot of y'all don't have graph paper. I've got a whole stack of it. I could have easily used graph paper. But I wanted to show you how just simply using a ruler creates a very accurate and clean graph, okay? I just used the lines of my paper for my y-axis, and for my x-axis, I measured the distance between the blue lines was about, I think it was 1 centimeter. So I just used centimeters and marked that off for my x-axis. So it creates almost a perfect grid. You can tell it's not quite right? This is a little bit wider than this is tall, but it's pretty darn close. And honestly, the scale can be a little bit different as long as they're equal intervals. This space is 1, that equivalent space is also 1, that equivalent space is also 1. Okay? They just can't be different size intervals. Anyway, so I come down here and I inspect this point. Okay, what is this point? What are the coordinates? Well, it looks like, and this is an estimate, right? I have to eyeball it because this isn't perfect. Even if it was on graph paper, you're going to have to eyeball it. So I'm going to go out 1, 2.5. That should be my x value of the coordinate. The y value, down 1, 2, should be -2. So my solution is x equals 2.5, y equals -2, according to my graph. Okay? Now, I need to test that solution. So one of the assignments was, how do you test a solution? And this is the way you test a solution. You take the coordinates of that solution and you enter it, substitute it, plug it into whatever verb you want to use, into each of the equations. So here is the solution, 2.5 comma -2, right? And what I'm going to do is I'm going to go ahead and substitute my x and y value into the original equation. Now, the original equation, no rewritten equation, no different version of the equation, the original equation, just to make sure that if you had an error somewhere, that we're not compounding that error, okay? So in the original equation, I substitute 2.5 for x, I substitute -2 for y, and 4 times 2.5 is 10. Double check it, you can put it in the calculator. 2 times a -2 is a -4, and sure enough, 10 minus 4 is 6. Therefore, this point is on this line. It satisfies this equation, makes it true. So let's try it in the red one. X is 2.5, I substitute. Y is -2, I substitute. 2 times 2.5 is 5. A negative times a negative, so a negative, subtracting -2 is the same as adding 2, right? Hopefully you remember this from 7th grade. Subtracting a negative is the same as adding a positive, right? If you owe someone $10 and I take away what you owe them, so you no longer owe them $10, it's the same thing as giving you $10, right? If I take away $10 or I give you $10, take away the -$10, either way you're $10 richer, right? Okay, good. So a negative is a positive. And sure enough, 5 plus 2 is 7. So this point exists and satisfies both lines. Okay, now we're to the final question that you were asked. We found intercepts. We graphed lines based on those intercepts. We found the point of intersection from our graph, and we tested that point of intersection. The next thing that I asked you to do was to rewrite those equations. Here are those equations, and we're going to talk about rewriting them. Rewriting the first equation. I asked that you rewrite them in slope-intercept form. Right now, they're in standard form. So in order to get them into slope-intercept form, we need to isolate y. We need to get them into the y equals mx plus b configuration, okay? So we need to get y by itself. So we go ahead and leave our y terms alone and instead subtract 4x from each side. Now 6 isn't a group of x's, so we can't subtract 4 from 6. We just leave them separate. Okay, subtracting away 4x makes this 0. 0 plus 2y is just 2y. Now, I put the x's first because we're trying to get it into that form anyway, right? Y equals mx plus b, so we want the x's first. So the negative 4x just stays negative 4x. The positive 6 just stays positive 6. We can't combine them in any way, okay? Next step. The 2 being multiplied by the y is a problem. I don't care about 2y, I just want 1y. So the way I make that 2 times 2, a 1, is I divide by 2. Right? The inverse operation of multiplication is division. So I'm going to go ahead and do 2 divided by 2. Now if I do that, I have to divide everything by 2. Every single term, everything that's separated by a plus or minus sign, it's a basic rule, is going to be a separate term, and I need to divide each of them by 2. All right? Now, we might have talked about this in class. I want you to think about shrinking a person. So like, I don't know if you all have seen Honey, I Shrunk the Kids, but anyway, you guys get the concept of shrinking. So Ant-Man, whatever. If you make his, let's work with Ant-Man. If you make his head 1/2 the size, so you divide it, right? We're going to divide his head in half as far as size goes. So half the width, half the height, half the depth. Half. If you don't do that to all the other parts, Ant-Man's going to be walking around with a little pea head, right? Like a little mini head on top of his shoulders. So if you're going to divide something and keep it proportionally equal, right, to keep it functionally equal to its original form, you need to make sure to divide every single part, right? Like, and same thing for multiplication. So this is a concept called scaling, right? So we're going to scale this function down by a factor of 2, same way you would scale down Ant-Man by a percentage, right? You're not just going to shrink his head by 50%, you're going to shrink the arms, chest, legs, the whole shebang, right? Okay, so that's what I did here. 2 divided by 2 is 1y. Negative 4 divided by 2, I went ahead and wrote it. Negative 4 divided by 2 so you could see it. 6 divided by 2 is just that, 6 divided by 2. And then I went ahead and took the extra step of showing you these fractions before I simplified. 4 divided by 2 is 2. Don't forget your negative. 6 divided by 2 is 3. Bam. Y equals mx plus b. Perfect. So now over here. Over here, we have the original equation, 2x minus y equals 7. Same thing we did before. We're going to subtract away the group of x's, minus 2x from both sides. Can't combine groups of x's in just a plain old 7, a constant of 7. So we keep them separate. Now, this is unique, right? A negative y. How do I get rid of just a negative? That's annoying. Well, if you divide by negative 1, a negative divided by a negative is a positive. Awesome. Y divided by 1 is just y. Awesome. Same thing as before, we need to divide everything by that negative. So this negative divided by a negative is a positive. 2x divided by 1 is 2x. This positive divided by a negative is a negative. 7 divided by 1 is 7. Okay, so now we have both of our equations rewritten in y equals mx plus b, or slope-intercept form. Final step. I know, we're almost half an hour here. Final step. Let's make sure that our rewritten equations match our graph. Because don't forget, this is just a rewritten version of this. It's still the same function, should still be the same graph. Absolutely, right? So why not? Let's go double check. These are in slope-intercept form. We know how slopes and intercepts work. Let's go check it out. So here we are. There's our equations rewritten in slope-intercept form, right? So let's see if these make sense according to this graph. So here's our pencil graph, right? According to this equation, I should have a y-intercept of 3 and a slope of negative 2. So let's come over here to the graph. Y-intercept of 3, positive 3, perfect. A slope of negative 2. So that means I should go down 2, 1, 2, over 1. Yep, and back on my line. Down 2, 1, 2, over 1. And back on my line. Down 2, 1, 2, over 1. And back on my line. Therefore, this equation represents this graph. Last one, red line. According to this equation, I have a slope of, a slope of positive 2 and a y-intercept of negative 7. So I'm going to come here to my y-intercept of negative 7. Yep, my red line passes right through that. Perfect. When x is 0, y is negative 7. Awesome. And my slope is positive 2, which means I should be able to go up 2, rise, over run, over 1. Rise 2, over 1. Because we know that a whole number is also the same as that whole number divided by 1, right? So 2 over 1. So up 2, over 1, up 2, over 1. Yep, that equation represents my red line. So guys, this was a lot in one assignment, and hopefully in watching this video you learned a lot, because this summarizes almost like a semester's worth of work in one assignment. All right, we are isolating variables, we're solving equations, we're substituting variables, we are rewriting equations, we're understanding slope-intercept form, we're understanding standard equations or linear equations written in standard form. We're talking about graphing here. We're talking about recognizing slope. We're talking about intervals. There's a lot in this, and I really hope you spent enough time digging into it. If you gave it a shot and you're a little bit off, cool, fix it. If you gave it a shot and you were way off, that's okay. Watch this video again and ask me questions, okay? Or ask whoever sent you this video. Ask questions, okay? I'm going to send you guys out another assignment similar to this one. And if you're watching this video at a time other than, May of 2020, then that's not going to make any sense at all. Anyway, if you know me well, you know I'm horrible at ending videos. Hope you're well. Talk to you later. Good luck.